Hello Year 12s, this is another presentation that I'm making to you. The concept that I'm going to present on this time is addition of ordinates, and mainly the addition of ordinates questions came from 1D. And I thought what I'd ask you to do is to try to sketch this graph here. Now this graph here is a combination of two graphs. Now we know what y equals x looks like. Y equals x is a straight line right through the origin. The x-axis there, and the y-axis there. And next to it, what about if I say, well, here's the y-axis there, here's the x-axis there. What I want to do is to sketch 1 over x squared. Now that's a basic truncus, and it would go like that, and like that. So what about if we had to add these two graphs together? What would they look like? Well, let's see, we'd still have to have an asymptote down the centre there. So even though this was 0 at 0, this one's undefined, so there's going to be an asymptote right down the centre there. So if I said y there and x there. Now, I'm guessing that if we said, well, we need to add these parts together. See how this is a big negative part down here, but a small positive part up there. So this big negative part, if we'll add that to this small positive part, it would still be quite negative. So somewhere down there. And then as we get closer and closer to the x-axis, see how this particular part is close to, well, getting really big, and this part down here, really small and negative. So if we add those parts together, our graph is going to come up like this. And it's going to be, this part of the graph up here is going to be an asymptote near to the y-axis. There'll also be another asymptote through here at y equals x, because with the truncus here, it'll never reach the x-axis because it'll always be a little bit above, because no matter what the x value is, there's always going to be a little bit of the truncus added on to that. Now, if we're adding on this bit here to this bit here, now see how the small values of x are really small y values here, but the small values of x are really big y values here. So if we add a small y value and a large y value, we'll get a graph that looks like that. Alrighty, hopefully that's helped a bit. I'll give you one more example. What about if we try to sketch y equals x squared plus x? Now let's sketch both of these graphs again. Now y equals x squared is a parabola, so it goes like that, y equals x squared. And y equals 1 over x, that's an ordinary hyperbola, and it'll go something like this, y equals 1 over x. But if we combine the two of these together, what will the graph look like? Well, let's see. If we sort of look out here where the x values are large, well, there's large y values there and really small y values there. So if we add that and that part together, it'll start up here with some large x values. Now there'll be some point here when this part here is above the x-axis, the same distance is to this below it. So when we add this y value with this y value, we'll get an intercept. And then see how y equals 1 over x zooms off towards infinity. I'm guessing our graph would kind of look a bit like this. Now, can you see how for small x values, the y values for the parabola are really small, but for little values of x, the y values here are really big. But further out, when we have bigger x values, the y values here are really big, but really small over here. And in the middle here, this is where there'll be a minimum, because our graph will go a little bit like this. Alrighty, well, I hope that helped a little bit. And this graph here is what y equals x squared plus 1 over x looks like. Okay, so far we've done two addition of ordinates graphs with plus between them. What happens if we have a problem like this, where there's a negative between them? How can we use addition of ordinates? Well, y equals x looks like this. There's the graph of y equals x. Now, rather than try to do subtraction of ordinates, subtracting the y values, what about if we decided we'll sketch the graph of y equals minus 1 over x squared? Well, that would be a truncus that was flipped upside down like this. And then what if we combine these two by adding them together? Well, the y coordinates over here, where x is really large, would be a combination of a large negative number and a small negative number. Well, a large negative number plus a small negative number will be an even larger negative number. Now, as we kind of move into the middle of the graph here, where there's kind of like a mid-range x value, there'd be a medium y value and a sort of a smallish y value, so somewhere up here. But then as we get closer to x equals 0, there'll be a small y value and a really large y value here. So if we kind of add the y values for there together, what that means is we'll come up and we'll turn around and we'll head back down, because when the x values are really big, it's a combination of y values that are really large and negative there, and really small and negative up there. Somewhere in the middle, mid-sized kind of y value, smallish y value, and close to where x is 0 at about here, small x value on a small y value on the linear graph part, large y value, large y value on the negative truncus part. So our graph will kind of go up like this. Alrighty, where x equals a positive number, small positive number, small positive y value, large negative y value when x is small. So our graph will be starting down there, because if we add a small positive y value with a large negative y value, we'll still get a large negative y value. Somewhere in the middle here, we'll get, say, about here on the graph, and I've tried to mark them about the same distance away so the x values are the same. Small positive y value, small negative y value. So they'll kind of cancel out when we add the y values together here and create a intercept. And then as we get into the large x values, large y value, small negative y value. So that'll kind of go off there. So our graph will come up like this, and there'll be an asymptote at y equals x. And another asymptote, I guess, down the middle. I'll label that asymptote, y equals x. And another asymptote at x equals 0. Alrighty, Year 12s, I hope that's helped. If you have any more questions about addition of ordinates, ask in class.